Welcome to my channel, everyone. This is Todd from Next Level Adventures, and today's video is all about my custom winch install in this 2005 Toyota Tundra. I've been slowly converting this into my overland vehicle, and I've got a lot of cool projects planned for it. An e-locker install, my own mini snorkel design, and my own custom topper lift. So if you find these projects interesting and you don't want to miss a video, please hit the subscribe button. Today's video, though, is all about my winch install. Now, I'm a big fan of the way this truck looks. I like the old school looks, the chrome and all that. And so I'm going to try to package this winch behind the fascia of the front bumper. And try to make it look as OEM as I can. You know, something that maybe Toyota would do if they were putting a winch on this truck. This is what the truck looks like without the front bumper system. What I was trying to do is get a feel for, where can I bolt my winch plate to? Obviously, you want to bolt it to the frame since that's the strongest part of the truck. But one thing I did notice is that this truck has a ton of overspray on the fender liners, and the flanges that were originally welded to the ends of the frame rails, they were pretty mangled. So it became really obvious that the previous owner had bumped into something. And so this is what the flanges look like. They were just too bent to use, and it would have just taken too much work to try to straighten them. So I ended up cutting the welds off. I ground the welds away and peeled the flanges off. I'll just bolt my winch mounting plate directly to the frame. What you're seeing here is a mock-up. So I'm trying to get an up and down height position for this winch. Again, I want to use the OEM bumper cap, and I want the fairlead to come out at a really nice transition point on that bumper cap. So again, it looks like maybe something Toyota might have done. And so that's what I'm doing here. I have the winch mounted to a universal winch plate that I bought from Harbor Freight. I'm not going to use it, but it's really helpful for all the mock-up that I'm doing. Now that I had a pretty good idea of where I could bolt things to the frame of the truck, now it's design time. And so I'm using SolidWorks to help lay out what my winch system is going to look like. And when the bumper system was off, I took a bunch of measurements, and now I'm converting those measurements into a 3D model. And so what you're seeing here is the base plate. This base plate will bolt directly to the frame rails of the truck. The winch itself will bolt directly to this base plate. The recovery hooks that I'm designing in will also bolt directly to this base plate. So this base plate has to be really strong. It's going to be made out of 3/8 inch mild steel. I'm going to have it laser cut out. It's all one piece. I don't want the base plate to be welded together because I want maximum strength. So one of the benefits of creating all the models in 3D is that you can take all these individual parts and you can put them into a top level assembly. And so what you're seeing here is that top level assembly with all the individual parts. The two uprights on each side, the hole going through them, there will be an M14 bolt going through the sides of the frame rails. So those uprights will straddle the sides of the frame rails. There will be two M14 bolts coming up from the bottom of the base plate into the bottom of the frame rail on the truck. That spacer between the two uprights, that's to lower the whole winch system down a little bit. There's a sheet metal bracket that's right above the winch, and I don't want to have to modify that, so I'm just going to lower everything. There will be a decent amount of welding with this whole mounting system. I'm going to TIG weld everything together. The frame rail that's on the back of the whole mounting system, that will get welded to the base plate. The two side supports on each side, I'll TIG weld those to the base plate. And then finally the fairlead mounting flange and its side supports, those will get welded to the base plate. So everything will add to the stiffness of the base plate. The recovery hooks will have two side supports on each side, and they will get welded to the recovery hooks themselves. And each recovery hook will have 4 M14 bolts securing the recovery hook to the base plate. So it should be very stout. Now, when I designed this system, safety was the #1 priority. I don't want things breaking on this when it's in use. So, for example, if I'm stuck in a mud hole and someone's trying to pull me out, if they use a kinetic recovery strap on one of my recovery hooks, I don't want those recovery hooks separating from my vehicle. Each of those recovery hooks is probably 3 or 4 pounds, and attaching, when those things are attached to what amounts to a big rubber band, I don't want those recovery hooks flying through the air. They could hurt somebody. So safety on this entire winch mounting system was my #1 priority. And so in the next section, you'll see some of my calculations on how I determine, what bolt sizes to use, what grade bolts to use. Just some simple stress calculations.
One of the ways to calculate the shear strength of the bolt, which is what we're looking for, is to first understand what the tensile strength of the bolt is. So I'm choosing M14 bolts, and I'm using grade 10.9, which is a fairly good grade. So the tensile strength of an M14 bolt is 108 kilonewtons. Now, to get the shear strength of that bolt, it's widely understood that you take 60% of the tensile strength, and that will give you the shear strength of the bolt, which is 64.8 kilonewtons, or approximately 14,500 pounds. And this is per bolt. Now, on my recovery hooks, if everything was just in a pure shear motion, so this is my recovery hook, and these are the bolts that are holding it. There's 4 bolts holding it. So if I just pulled straight, not like this, but just straight, I could take that 14,500 times 4, and I think it's somewhere around 60,000 pounds. So that's what one recovery hook can handle if it was just pulled in pure shear.
All right, so what does the 60,000 pound shear force capacity even mean in real life? Well, my truck weighs approximately 6,000 pounds, and if it was buried in a mud hole all the way up to the body, it would probably take somewhere in the neighborhood of 20,000 pounds to pull that truck out. And so if one of your recovery hooks can withstand 60,000 pounds of force and shear, in my opinion, you have some pretty stout recovery hooks.
The last example I showed was a best case condition, and that was a condition where the bolts can handle the most shear strength. So now what I'm going to show you is the worst case condition. And so what I'm creating here is a free body diagram of my recovery hook. So this is a recovery hook. This is where the shackle would go. And then this is a top view of the recovery hook. So if you're looking straight down at the recovery hook, this is what it would look like. You have the 4 bolts here and here. And then we're going to apply a load here, P, and I'm just throwing it out an arbitrary load of 10,000 pounds. And we're going to make it 90 degrees to the body of the recovery hook. That will give us a worst case condition, because now you have this big leverage arm here. And the more shallow the load, so if we're pulling parallel to the length of the body, that's going to be the best case condition again. Okay, so we're going to do a load 90 degrees to the body of the recovery hook. And to calculate that, you need some equations. Because this is a static model, nothing's moving, the sum of the forces is going to equal 0. And so we have a load P, which is equal to F1, which is this load, plus F2, which is this load. Okay, so if these didn't equal 0, this thing would be moving. This would be spinning or something. So it's static. Sum of the forces must be equal to 0. Now we know what P is, but we don't know what F1 and F2 are. And with this we only have one equation, so we need another equation to be able to solve one of these variables. And so the equation that we're going to use is the sum of the moments. And the sum of the moments has to also be equal to 0, because again, this thing's not moving. And so we have P times 4 inches is equal. So I'm going to assume we're revolving around this area. So it's equal to F2 times 4.5 inches. Okay, so F2 equals 10,000 times 4 divided by 4.5. And so 10,000, okay, so 8,900. And this is pounds, okay? So F2, this location is seeing 8,900 pounds, which isn't much because each of these bolts can handle 14,500 pounds. So really good factor of safety there. No problem about sharing the bolts at location F2. F1 equals P minus F2. So P is minus 10,000 because we're going in a different direction than F2, minus F2, which is 8,900, which is equal to 10,000 or 18,900 pounds. Okay, so the load that we're seeing in this location at F1 is 18,900 pounds. Now, because we have two bolts there, we can handle approximately 29,000 pounds. So we're still okay there. So these two bolts, if we apply a 10,000 pound load 90 degrees to the body of this recovery hook, it'll apply 18,900. These two bolts will see 18,900 pounds, but these two bolts can also handle 29,000 pounds. So that's how I rationalize some of the sizes of the bolts, some of the grades of the bolts, and even the thickness of the materials and such. These are just rough calculations, just ballpark figures.
So we went from the virtual world of creating all of these 3D models on our computer to the physical world where we have the parts on hand, which is what you're seeing here. Now, one of the benefits of spending all that time creating these 3D models is that I can give these models to my metal shop and they can use these models to create a CNC program to cut these parts out. And that's exactly what happened here. All right, so this is the base plate. This is the foundation for the entire winch mounting system. This is what the winch will bolt directly to. This will bolt directly to the bottom of the frame of the truck. What I'm showing here is a fair lead flange. That'll get welded to the base plate. It's tabbed so I don't have to figure out where it should be mounted. It just registers itself to the base plate. And then the supports, I scalloped everything out so that water, etc., flushes out of it. This is the stiffening rib for the base plate. It'll get TIG welded in all these little areas, and then again heavily scalloped out so that if water and such should get in there, it'll flush right out of the system. These are the recovery hooks. They are made out of 1-inch thick hot rolled mild steel. Surface cut quality isn't all that great just because the material was just so thick to cut. Their laser had a hard time cutting this thick of a material, but not a big deal. I'll just grind it down and make it look pretty. And then the side supports for each of the recovery hooks. So those side supports will get TIG welded to the body of the recovery hook. And then once that's done, I will drill and tap 4 M14 threaded holes into each recovery hook, which will then just get bolted directly to the base plate. Now, these are spacers, and these spacers will get sandwiched between the base plate and the bottom of the frame rail. And their only purpose is just to lower the entire winch mounting system. There's a sheet metal support bracket right above the winch, and if I don't lower the entire winch mounting system, I'll have to cut or modify the bracket, and I don't want to do that. These are threaded support plates. Each side of the frame rail will have 3 threaded support plates. So when I go to bolt this winch mounting system up to the frame rail, the bolts going through the frame rail will thread into these threaded support plates, and that should give it a whole bunch of strength. The side plates will straddle and bolt to the sides of the frame rails with one M14 bolt per plate. The M14 bolts will screw into these threaded plates that are located on the inside of the frame rails. I test fit everything on the truck. Everything fits really well. All the parts fit together really well. It's time to tack weld everything together and get ready for complete welding. Before I can do that, I need to grind off the mill scale that's on these parts. These parts are all made out of hot rolled mild steel, and it has this oxide coating that doesn't allow it to weld very well. So if you try welding over the oxide layer, it's going to come out crappy. I'm going to take a grinder to it, a 4-inch grinder, and I'm just going to start grinding all the areas that are going to get welded. And I'm going to grind off that oxide layer, so when I go to weld it, it's nice and clean base metal. That table that you see me grinding all the parts on, that is a downdraft table. I made that several years ago, so any cutting and grinding, or if I'm plasma cutting something, I do it on this table. It sucks all the fumes down, pulls it through a welding filter, and then discharges it to the outside. Just keeps the whole garage much cleaner. Now that I have all the mill scale ground off, I'm test fitting it for hopefully the last time. So I'm going to mount it on the truck, I'm going to tighten all the bolts, and once I have everything correctly positioned, I'm going to MIG weld, or I'm going to tack weld everything together with my MIG welder. Once everything's tack welded together, I'm going to pull it off the truck and finish all the welds using my TIG welder. Welder I'm using to tack weld everything together is a Lincoln Power MIG 256. All I'm doing here is tack welding some support braces to the parts before they get welded. And I'm doing that because when you weld something, things tend to move around, they tend to warp. And the frame fits in between those two side plates. So I don't want that gap closing up, otherwise it's not going to go onto it's not going to fit onto the frame correctly. And so I'm just going to tack this piece of L bracket to the two side plates to maintain that correct space. And just an FYI, if you guys are interested, the TIG welder that I have is a Miller Dynasty 280DX with a water-cooled torch. All I'm doing here is adding more tack welds to the pieces so they don't move around when I start welding them full length. If it looks like I had a very uncomfortable body position when I was welding, it's because I had a very uncomfortable body position when I was welding. Because of the length of the base plate and the size of my welding table, I just couldn't, and because I was trying to film at the same time, it just made it very difficult to get a good, comfortable welding position. For all you welders out there, I am using an Optrel Crystal 2.0 welding helmet. This thing is off the charts in terms of clarity when you're welding. You can see everything with really good detail. You saw me MIG welding with a Jackson BH3 welding helmet. Another great helmet, but this Optrel Crystal 2.0, the clarity is just unbelievable. I want to say that I've had really cheap welding helmets, these $20 auto changing helmets. The mid-price helmet, which is the Jackson BH3, and that was, when I say mid-price, that was still $350. But this Crystal 2.0 is more towards the top end, and I think this was $470-ish, somewhere around there. But I thought the Jackson BH3 was great. This Optrel is even better in terms of clarity and being able to see what you're welding. One of the problems I had was the base plate warping when I welded the two side plates on. So I ground out the welds on the side plates, and I mounted the whole base plate into this crazy looking fixture. That heavy chunk of steel underneath there is from an old milling table that I had. And then if you look at right under the side plate on the inside, there's a rod going under it. And so I put a bunch of weight at the opposite end of the base plate to load it. And so when I go to weld the base, that side plate to the base plate, it's going to stress relieve everything and straighten everything out. And that's exactly what it did. So lesson learned, from now on, I welded everything on the milling table. Kept everything nice and straight, warp free. Alright, so this is what it looks like with all the TIG welding done to the base plate assembly. There was a ton of welding involved, but came out really nice. Everything is nice and straight and flat, which is fantastic. So now I'm off to welding the recovery hooks. Now that all the welding is done on the base plate, I can move on to the recovery hooks and weld these together. So right now I have everything tack welded together, so the side supports are already tack welded to the main body of the recovery hook. I do have a piece of paper under the main body of the recovery hook because I'm trying to space it up. After I weld everything, I'm going to come back and face mill the bottom of it flat, and I'm just trying to take as little material away from the main body as possible. So that's the reason why I'm spacing it up. I also heavily chamfered the edges of the side supports where I'm going to be welding it. I'm just trying to get maximum weld penetration and maximum strength out of it. So when I weld this, when I finished welding it, I think I ran 3 full passes around each of those side supports to get the fillet size that I was looking for. Welding on the recovery hook is finished. I think I ran 3 full TIG welding passes around each of those side supports. Next thing I'm going to do is put it in the Bridgeport and flatten the whole thing out. So after I finish all the welding on the recovery hooks, I wanted the bottom to be flat because when it gets bolted to the base plate, I don't want it rocking or trying to warp out the base plate. So I'm putting it in my Bridgeport mill and I have it upside down. So now I'm flattening the bottom of it. I'm using a face mill and I'm just running it across the entire length of the recovery hook just to make sure everything is flat. So when I go to bolt it to the base plate, everything is nice and flush. To protect all the metal surfaces, I painted everything with Por 15 top coat. I used chassis black as a color. Not crazy about the sheen that it leaves on the parts, but my main focus was to protect the metal itself. Por 15 dries really rock hard, and I've used it in the past. It does a really good job of protecting the material. So the sheen or whatever's going on there, it doesn't really matter to me, as long as the metal is protected. Okay guys, we are one step closer to finishing this project. It's been months worth of design time and fabrication and welding time, but it's all coming together. Winches bolted up to the base plate for the last time, same with the recovery hooks. Next step is just bolting into the truck. Alright, it's bolted up to the truck for the last time, hopefully. You can see through the frame rails, you can see the threaded plates sandwiching the frame rails. So you have 2 M14 bolts coming up from the bottom and then 1 M14 bolt coming through each side of the frame rails, securely attaching this whole winch mount system to the frame rail. Everything's painted with Por 15. While I had everything apart, painted the frame rails inside and out with Por 15. Just tried to do as much as I could to protect everything since everything was apart anyway. But it's finally together. Now that the winch is finally mounted to the front of the truck, I can concentrate on getting the electrical system complete. What I'm doing right now is finding a home for the master disconnect switch for the winch. I made an aluminum plate that I'm going to mount the switch to, and those big heavy cables, I'm going to be mounting those to my new V-gate battery terminals. Alright, the electrical system is complete, came out really nice and clean, protected all the wires from abrasion. The winch location is absolutely perfect. I can have plenty of room to get my hand in there so I can turn the lever to engage or free spool the winch or connect up my remote control to it. So all the effort that I put into it, into the design of the winch up front, has really paid off in the end because everything is really working well together. To mount the power steering lines, I just used a couple standoffs, and I just bolted it directly to one of the sheet metal parts of the truck. Alright, so this is what the front of the truck looks like. I think I did a pretty decent job of keeping the classic lines of this truck intact by packaging the winch system behind the front bumper system. You know, the recovery hooks are coming out just the correct amount. The fair lead of the winch is at the correct height. I can even mount the license plate in the original location. The base plate of the winch is so strong. I have the skid plate of the truck bolted to it. Everything on this build exceeded my expectations. I'm really happy with how everything came out. The functionality of the system, the aesthetics, everything really came together at the end. So if you guys enjoyed watching this video, please do me a favor, hit the subscribe button and hit the like button. My next video is going to be installing my TRE 4x4 e-locker, so stay tuned for that. Thank you.